Marcello will have a speech on model strategies for water management for open field crops. Please, Marcello.
Grazie Antonio, good evening to everybody. It's enough to speak about irrigation, and in this section, my keynote, I will not present you data on irrigation, but only on, we come back to the agronomy. So, I will try to start with this work in this direction, or in this direction.
It doesn't work.
Doesn't work this. Okay. I come back. Okay. To introduce my speech, I want to start from the climate change. So, also among the scientific community, there is people which doesn't trust in climatic change, so we don't hurt the sensibility of this person. And I show you only the measurement here. Here, the black line is the measurement, the measured data on temperature anomalies at the global scale, at the level of land, at the level of oceans. So these are the measured anomalies, and the red and the blue traits are model simulation. The red is done considering also the anthropogenic effect, and the blue line are simulation made only on natural effect. So it is clear that this anomaly follows what happened after the human action. So this is not a simulation. I have to go here. And this is what happened at level in the different continents. It's clear that what is happening here in the Mediterranean zone is the most dramatic change, dramatic anomalies. So this is a hotspot zone. We have measured the higher temperature in the future, but now for people who is dealing with irrigation, we have to consider also the rainfall. And the effect of the measured data on rainfall is here, that we have more rainfall variability and a greater frequency of extreme events. This graph here is again data which have been measured, and this time have been measured in our institute in Foggia. It's 100 kilometers north from Bari. And you see what happened in the last 50 years. We have lost 100 millimeters of rain, and we have here there is a break point in this year, and in the second half of this long series of data, you can see that there is apart a lowering in rainfall events, also a higher variability in this data. All this variability provoke a water shortage at the level of our crops. So we can say that we don't know what will happen in the future, but we know that there are these anomalies, and these anomalies concern temperature and concern rainfall. So the impact of these two factors on crops depends. Yes, it depends on the geographic position size, but it depends also on the capacity of the farmer to cope with this change. If our farmers are able to change their behavior. So for the farmer, the easy way is to supply more water when there is water scarcity. But in reality, we have two behaviors. We have the behavior of the farm, which are, since now they are working at their level, and they are performed new strategies for contain the water stress. And the agronomic research is going on with new issues. So the aim of my keynote is to discuss these issues in the specific context of the IrriMED, to seek a particular solution to on-farm problems, and to bridge the gap between the practice and the science. So, the water source for the open field crops is the rain. The rainfall is the essential, and then there is also the irrigation, but first is the rain. In that graphic, you can see here what it means, drought in the Mediterranean countries. There are the lands where the drought is 7 months long, and being other sides where the drought is between 1 and 3 months long. And we have to operate in this condition. So this is the evolution in time of the rainfall and of annual crop. You see here that when the evapotranspiration of the crop increases, then the rainfall are going down. So we have to cope with this situation. So the problem is to store water in the soil and to allow to the last part of the crop stage to uptake water in the soil reservoir. The water sources for the open field crops are essentially the rainfall. The rainfall arrives in the soil, the plant uptake the water, and the water come back in the atmosphere as evapotranspiration. But we have loss of water as evaporation from the soil and as runoff. But we have considered that the runoff that is not utilized by me is utilized by other farmers, and at the same time the water which is evaporated into the soil contributes to the mitigation of our climate. So we have to consider also this aspect when we consider the water cycle. And then the deep percolation, and so what remains in the soil, what is stored in the soil, is available to the roots for crop which grow in the dry seasons. The consequence of soil drought on crop productivity. So it's a very delicate point because we have to define exactly what is a drought. This is what we made in laboratory. This is an experiment made on grain sorghum, and we had exactly measured from the point of view of the plant what is a drought. We have measured by means of pre-down leaf water potential what happens in a crop which is constantly irrigated. So you see that it is stable along all the cycle. And we have applied also two kinds of stress, and in red dramatic stress and a mild stress in this brown color. So in laboratory we are able to measure, to define exactly how much is the stress in terms of intensity of stress, and also in terms of when the the stress is localized within the crop cycle, if it is of the flower, or the flower setting, the seed setting, and so on. But we have to move from our laboratory to the open field. So my speech my talk will be divided in three parts. The first here, innovation. The second, the good practices. And the third, I have called the fine-tuning research, which represent a bridge between the research and the good practice that the farmer had just applied. Innovation. The innovation comes from the contamination between the different sciences. When the agronomy is contaminated by the informatics, we have this kind of results. We have the DSS, decision support system. This is quite a list of the decision support systems. They are quite frequent in literature and in practice also. So this kind of instruments are used for the management of reduced quantity of irrigation water. But please, you take in mind that the agronomic strategies for saving water affect more the water amount and less the production levels. This kind of decision support system are easily to be used in the field, in the experience, if we have a connection in real time with the network of agrometeorological stations. Another innovation is the proximal sensing. Here you see a sketch of a drone or another robot which walk on the field and they capture several images, capture information. All these informations are elaborated for what we call the precision irrigation. Another example is the remote sensing. This is used to control the water distribution at the regional scale. Another kind of contamination of science is the relationship between the agronomy and biotechnology. And in this case, we have the production of new hybrid of corn. In Europe, we can't use, in most countries of Europe, we don't use the OEGM organism, so with the traditional genetics breeding program, the biggest seed company has produced this kind of hybrid for the corn. However, I have to underline that when I go in the field and I test these hybrids, they doesn't respond very well. So now, what farmers effectively they do. And I will present the success factor and the fail factors. First of all, in this picture here, Van Gogh called this table landscape with plowman. Where is the plowman? The plowman is here. And the plowman is the farmer who preserved the environment. Now we have no more plowman, we have the tractor in our field, and what we try to do with conservative agriculture is to preserve our landscape, our soils. And in the concept of the conservative agriculture, the cropping system utilizes the soil without mixing the soil and maintain the crop residue in order to make a sort of mulch on the surface. So we prevent the evaporation and we create a roughness on the soil surface. So if there is a runoff, the runoff doesn't produce the erosion of the soil. The conservative agriculture provides an optimum environment for the root. The roots are able to function effectively. They go deeper into the soil, and if they found elements and water, they can utilize it easily. The water infiltrates into the soil so that the plants never suffer water stress, and the excess of water doesn't flow or doesn't remain, doesn't pointing at the surface or go out as runoff. With this conservative agriculture, the biological activity in the soil is improved, so it maintains and rebuilds the soil structure, compete with the potential soil pathogens, contribute to the soil organic matter, and contribute to capture, to retain, and to release the elements for the crop. And last, avoid physical and chemical damage to the root, because we don't go with deeper irrigation if you think deeper plowing in the soil. So this is the point of view of the water and the conservative agriculture. So the success factor is a higher infiltration, a decrease in evaporation, decrease in erosion, and also it's less expensive system. The fail factor is this list. Effectively, to apply the conservative agriculture is complex. It requires the skilled by the farmer, and the farmer should be convinced of the good effect of the conservative agriculture. It requires the weed control, so a lot of herbicide should be used. Not all crops are adapted to this kind of system. The horticultural crops are difficult to enter in the conservative agriculture. And there is in Italy or in Europe, but in Italy especially, we have a great tradition of using machine in the field. So we have a great tradition of plowing our soil, and this is very difficult to enter and to in the hand of our agriculture. Another strategy is the early drought cover. So how I can make this? If I make an early sowing or by seed priming, it means make some treatments to the seeds in order to that the germination is easier. Also sowing cultivar with early vigor, optimize plant density. The success factor is an increase of infiltration, decrease of evaporation, and the erosion, and it is a cheap system. The fail factor, that is very difficult to control the weeds. We can have a risk of early drought, and if there is a drought, our sowing could be failed, and I am obliged to resowing another time. Another technique is the deep tillage. This is not a contradiction with the conservative agriculture, because when I mention the deep tillage, I intend a sort of cut of the soil which arrive until to 60-70 centimeters into the soil. And this is necessary mainly when there is a hard soil layer into the soil profile. I need this kind of machine for making this cut into the soil. The success factor is higher infiltration, a higher development of root. The fail factor is the risk of erosion after the cut of the soil, and the fact that I have to repeat this tillage after 5 years, 6 years, depends. Another practice is the effective weed control. In this case, the success factor is a higher soil water, more soil water for the cash crop and not for the weeds. Is easy if I am allowed to utilize the herbicide. There is a less competition with the cash crop, and there are other agronomic benefits. The fail factor is that after the first treatment against the weeds, they can start again, and so the use of this kind of herbicide could be an environmental risk, and it is costly. Another practice is the crop residues management. The success factor are the increase of the soil organic matter into the soil, higher infiltration, and they are just practiced in Mediterranean. For the vineyards or for the olives, for example, this is a picture of an almond in our farm, which is covered by a trifolium. And this is another solution for the open field horticultural crops. We have an ecological service crop, a cover crop, and when the crop is high, is grown, then it is flattened with that yellow machine, and behind there are the cut which make this the place in the soil for the transplantation of the plants. The fail factor is that the cover crop compete for water, so they are not so diffuse in the Mediterranean countries, and there is the difficulty with the weed control, and there is the risk that perennial weeds starts in. I want to mention also this technique, the retaining hydrogel. These hydrogel often are used in horticultural crops, but in greenhouses. But it is mentioned, but there are a lot of colleagues who think that it could be applied also in open field. The success factor is that they increase the soil water content, but ineffective is expensive. Another important point is the traffic, control the traffic. Here you can see this map of the compactation profile, where the soil is more compact, increase the density of the soil, I have less infiltration, and when I go at the end of the story, the productivity is lowered. The problem is that it requires new machinery, for example tractor which have guided by GPS, and I need adapted machinery with the new wheels and so on. Other technique is to choose the cultivar or rootstock which have a big apparatus soil root system. The success factor is that the zone explored by the root system is higher, so we have a higher soil water available for the plant, and there is a prevention of the deep loosening of the microelements. Fail factor that I haven't all these new varieties. Another technique is the follow the set aside. The success factor that if I leave my field for 1 year, for 1 season, it increases the soil water content, and if I cultivate also a green leguminous crop, I can increase my N content into the soil, and I have also to sustain by the European community. But the fail factor is that is not effective in the shallow soil. So in our countries, in Apulia, tomorrow you will see Matera, and you will have an idea how this practice can be effective there. Another problem is that in 1 season I leave my field and I have no production, so it would be uneconomic for the farmers, and they resist to utilize this practice. So I go to the last part of my speech, what the bridge between the practice and the research, what I call fine-tuning. This is an example that should be improved in the following year. So this is the creation of micro-basin. This is a flat area, or this in a slopy area. So there are this kind of machine which make this little basin on the soil, so the water can be collected there. Or other solution is to create this small pots where there is a spot, and water is concentrated here where there is a sharp or there is a tree. Another kind of microbasin is this traditional microbasin that you can see here. So the conservative agriculture, before I told you that we know anything on conservative agriculture, but also the conservative agriculture need more research. For example, needs an amelioration of the varieties, because not all our varieties are adopted to this kind of soil. Mainly in the first part of the emergency, the root system should be real strong in order to compete with this hard layer of soil, and the varieties which are adapted for the conservative agriculture should be more vigorous, and they should be developed early in the first part of their life. I need new varieties, I need new machinery, because the machinery which are available here, are made in Argentina, or they come from big fields, so we have to restudy new machinery for our small fields. And how I told you before, not all the crops are adapted for the agricultural, for the conservative agriculture, so we have to study also for the horticultural crop, for example. And another problem is to find a new cover crop, and mainly which comes from our land, from the Mediterranean area, and they should supply also nitrogen, for example, to the crops. Another issue, another argument to discuss is the technical management, tactical management. Now the farmers, they doesn't read books, but they are connected to the internet, with the telephone, with the tablet, so we have to study new methods to transfer our knowledge to the farmers. Another problem is the genetic. So the advance in genetics is no more only one gene, but on traits. For example, in our case, we are studying the traits which control the drought. The drought is not controlled by only one genus, but from a series of genuses. So the phenotypization of the crops is a new argument for the agronomy. For example, the root system. I insist on the root system, and we want a deep root system because if I go deeper into the soil, the plant is stable. Yes, but I can also profit, the plant could also profit of light rains, the rains which remains on the surface of the ground. So if I have a varieties with a capillary root system also in the surface, I can utilize also this kind of water. So you can see that it's a question to study. Another important question is to develop a new genotype which are sensitive to the low temperature. Why? Because if you take a crop which is sowing in the spring, if I can anticipate this sowing, I can save the irrigation during the end of the winter and the beginning of the spring when the rainfall falls. So I need new varieties which are resistant to the cold, So this is another hypothesis, for example, for the rice. We transform the rice in a C4 crop, but I told you that in Europe we haven't the possibility to use the OGM organism. And we pay a gap between our agriculture, our improvement in genetic with what is made abroad in China or in India and Brazil. And other studies requires also the new irrigation systems, the new materials. For example, this is the oxygenation of water for the surface irrigation, and after my presentation, Ambiatef will have a talk on this subject. The new technology concern also the improving of irrigation scheduling through the precision irrigation, which is time to be applied in field. And so we have also a set of new items like the subflow, the head covariance, or the nanosensor, which merit to be used in open field crop. The monitoring of the size of the fruit, the color of the fruit, for example, and a new model for scheduling the irrigation. So, conclusive remarks. These strategies are ready to be adopted. Each strategy can be widely applicable. Specific conditions should be considered, so each technique is valid locally, and other technique should be tuned for be applied in a place. And more research is required. And in my talk, you have an idea that we need some research which is needs only to adapt the existing good practice, and we need also extensive research for which concern genotypes, which concern materials and new sensors. And I want to finish with this question mark. And how it's possible to facilitate, to communicate these new potential strategies with the farmers. That is another question for the future. Thank you.
Thank you, Marcello, for this overview on conservative agriculture and for this point of view. We can open discussion. Is there any question? No question. Please.
Thank you for your presentation. You made a very complete review of all the strategies that can be used for open field crops. How can we imagine to merge modern needings for high quality, fast growing agriculture with the reintegration of traditional agronomical, or you mean to create which exists actually, to continue to have two different agriculture, one slow one and one very fast one, another one very fast. I don't know if I explained.
Two speed, the same agriculture with at two speeds.
Yes.
Okay. Ci sono anche magari così.
Any other question?
Thank you for your question. So I think that the agriculture is the only one we can. The objective is the same. The objective is to produce for feeding the people which are here, to give food, but give also flowers, give shadows to our cities. And I think that the agriculture should be sustainable. It means that we have to preserve the fertility of our soils, and I am convinced that the agriculture should be also highly productive. So I am thinking to a new agriculture which is made of new farmers that can continue to preserve the landscape, but with new technology. So I have mentioned to you the possibility of the precision agriculture, which is really a new frontier of our agriculture. In this case, you can apply to the crops the exact quantity of nutrients, of pesticide, or what you want, and in the right at the right place. And you can have excess of pesticide, of chemicals, and with the objective to sustain the landscape and to have a good production in terms of quality and of quantity. So this is an example. This is not a slogan, but we are working here all together for arrive to this kind of agriculture, which is based on information, on knowledges, and not on the empirism.
No other question? Okay, thank you, Marcello, for your speech. Next speaker is Giuseppe Loprione. The first year of comparison